Alright guys, welcome to our Unit 2, Quiz 2 study guide. In this video I'll go over the even problems. The odds are included as extra practice if you're interested, and the answers for those are provided at the end of the document. Alright, let's go ahead and start off here with number 2. It says you may use a graphing calculator or you can do this one by hand. I'll do it both ways, and you guys can do it either way you prefer on the day of the quiz. So let's go ahead and start by doing it by hand first. First we're going to go ahead and integrate. We're going to add 1 to our power and divide by that value. After that we do the fundamental theorem of calculus. That's where we plug the top number in and the bottom number in, and then subtract the results from each other. So we're plugging in 2 first, and then -3 second. From there we're going to go ahead and start simplifying the expression here. We have, notice that this negative is not inside the parentheses, so the negative is not going to be raised to the third power, only the 2 is. So 2 to the third power is 8, so the negative is still there, -8/3 plus 8. Once again over here, this -3 does have a negative in the parentheses, so the -3 is being raised to the third power. That's a -27. But there's also a negative on the outside, which makes the -27 become positive. So we have a positive 27/3, which is 9. And then 4 times -3 is -12. After you do your powers and multiplication, you can go ahead and distribute your negative to the second set of brackets there. And at that point, we can get rid of the brackets. So now the 9 is negative and the 12 is positive. We can add together all the numbers that are already the same kind. These are all just whole numbers. We could add these together. That's going to give me, let's see, that would be -1, that would be 11. And then we need to get a common denominator to combine these. So I'll put this over 1 and multiply the top and bottom by 3, which gives me 33/3. And if I combine 33 and 8, I end up with 25/3 would be my final answer there if I were doing it by hand without a calculator. Let's go ahead and demonstrate how to do it on a calculator. Now I showed you guys 2 ways to do it in class. I'll do it one way on our video here. So we're going to begin by pressing math. And then, actually, let's get out of there. First, we should put our function in. I believe our function was -x to the power of 2, and then plus 4. Now we'll go back to the home screen, second and quit. We're going to press math. We're going to choose option 9 for integral. And then we're going to put our lower limit in, -3, and our upper limit, which was 2. Make sure you don't mix up the negative and the minus. They are different buttons. Then we're going to put our function here, and instead of typing the function in, we already saved it under the y equals button under y1. So I'm going to simply put y1 there. You can use the vars option, which I've shown in previous videos, but I showed you guys a shortcut in class to get the y1, which is alpha trace, and then you can choose option 1 there. And there's my y1. Put an x there, push enter, and we get 8.3333. So that's the same answer I got in doing it by hand. It's just that this is a decimal version of the same answer. Right, so whether you do it by hand or with a calculator, both options will be available for you, but there it is. All right, let's go ahead and move on to question number 4. Now, whenever you're integrating an expression that has an inside function, that's probably going to be a u sub problem. So we're going to make the inside our u. Then we're going to find the derivative of u with respect to x, which is going to be 4x cubed. And we're going to get that dx by itself. First thing we do is multiply dx to the other side, and then we divide both sides by 4x cubed, and we end up with dx equals du over 4x cubed. And now we can do our u substitution. I'm going to replace this with u, so now it's u cubed. And then I'm going to replace dx with du over 4x cubed. These go away, and I'm left with this. And now we can just integrate using our power rule, which is to add 1 to the power and divide by that value. We don't want to forget our plus c. Then we finally, at the very end, we'll put our u back. The u was x to the 4th plus 1. And there's our final answer. Let's go ahead and move along to question number 6. Another u sub question. Notice I have an inside function again. So u is equal to 5x squared minus 4. Du over dx is equal to, let's see, going to multiply the 2 times the 5, that would be 10x, and then the 4 goes away. Getting the dx by itself would look like this. Doing our u substitution would look like this. Replacing this with the u, of course, and then replacing this with du over 10x. The 10x's go away, and we're left with a simpler expression here to integrate, where we can just use our power rule. Before we do that, we need to move that up to the top, making the exponent negative. Now we can add 1 to the power and divide by that value with a plus c. Now, at this point, I think I'm going to go ahead and move the u down to the bottom here so that the power is positive again. And then from there, we'll put the u back. The u was 5x squared plus, actually say minus 4. Oh, and I changed the power by accident. This was supposed to be a 3. There we go. All right. There's our final answer for that one. All right, let's take a look at number 8. My inside function here is x to the 5th minus 5. Take the derivative. Let's get that dx by itself. Ready for our u substitution. I'm going to replace the inside with a u. We're going to replace the dx with what it's equal to, du over 5x to the 4th. These go away, and I'm left with this. All right, the square root of u. Well, this is actually it's I goofed up here. There's supposed to be a 3 right here. This is a cube root. So you can imagine a 1 being there. So we're going to rewrite this as a 1/3 power. Then we're going to integrate it, and when we integrate it, we add 1 to the power, which gives us 4/3. Remember, I gave you guys a little shortcut for that, top plus bottom divided by bottom. And then typically we would divide by that, but when we divide by a fraction, that's the same as multiplying by the reciprocal. So we're going to do that instead. And then finally we can replace the u with x to the 5th minus 5. And there's our final answer on that one. Moving along to number 10. All right, my u would be the 5x minus 4. The derivative of u with respect to x is 5. And whenever I get the dx by itself, we get du over 5. Doing our u substitution, we're going to replace the parentheses with u, and we'll keep the fourth power on the outside there. 2x stays, and we're going to replace dx with du over 5. All right, now in this case we have an x left over. When that happens, what we're going to do is we're going to do a little bit of maneuvering here. First of all, I'm going to take this 2 and this 5, and I'm just going to move those to the very front here. And actually, I think also I'm going to put the u on the top here with that too. All right. So I'm just rearranging things. I put these three things together. The 2u to the fourth goes on top. The 5 goes on the bottom. And then I get this x here all by itself because I'm about ready to replace that x with something else. What am I going to replace it with? Well, I'm going to revisit this equation here. And I'm going to get the x by itself. So I'm going to start by adding 4 on both sides. And then I'm going to divide everything by 5. And that gives me u over 5 plus 4 over 5 equals x. And now I'm going to replace x with this now. And that will look like the following then. So we have the 2u to the fourth over 5. And in parentheses here, I'm going to have u over 5 plus 4 over 5. And then we have our du. All right, one more thing to take care of here before we're ready to integrate. I'm going to distribute this into the parentheses. So when I multiply these two things together, it becomes 2u to the fifth. And when I multiply these two things together, it becomes 25. Now when I multiply these two things together, I get 8u to the fourth. And once again, if I multiply these two things together here, I get 25. And we still have our du over here. Okay, now we're ready to start integrating. All right, so we're going to add 1 to our power. So that becomes 6. And then we're going to be dividing that fraction by 6 also. So I'll just put a 6 in the bottom. Repeat that process with the next one here. We have 8u, and we're going to add 1 to this power, making it a 5. And we already have a 25 in the bottom, but now we're going to put that power in the bottom also. And then we're going to have our plus c. All right. If you can reduce, now 8 can only be divided by 2 and 4, and neither one of those go into these bottom numbers here. So this fraction here is going to pretty much just stay the same. It's going to be 8 over 25 times 5, which is 125, and that would be u to the fifth power. On this other fraction, though, in the front, the 2 and the 6 can be reduced. So 2 goes into 6 3 times. So on the top, I'm left with a u to the 6th, and on the bottom, 25 times 3 is 75. All right. It might be helpful if we do one last way of rewriting this, just so it looks a little bit more like what you'll see on the multiple choice test. Technically, right now, we can go ahead and put our u back. But before we do, I want to show you how it'll probably look on the test. They're probably going to take these u's and they're going to drop them down to the side of the fraction. So it'll look more like this. And then we're going to put our u's in. And there's our final answer. All right, moving along. Number 12. This one says use u substitution to express each definite integral in terms of u, but you don't need to evaluate it. And so this just basically means after you do your u substitution, you can leave it. You don't have to actually do the integration. So the u in this case, once again, is going to be the inside portion. And we do our derivative of u with respect to x, which is 6x. We're going to get that dx by itself, which is going to be that. And we're going to do our integral. So we have 12x on the top. On the bottom, we're going to have u squared. And the dx is now being replaced with du over 6x. Now, we also need to change these numbers. So the way we do that is we're going to plug these numbers into our u formula here. So for the top one, I'll plug in a 3. And for our bottom one, we'll plug in a 0. All right, let's go ahead and simplify this. So the x's cancel out, and 6 goes into 12 twice. So we're left with 2 over u squared du. And then up here, exponents first. 3 to the second power is 9, and 9 times 3 is 27. Add 3 to that and you get 30. And for this one, 0 squared is 0, times 3 is 0, plus 3 is 3. And there is our final answer. We're going to stop there. We're not going to go any further than that, because it says just don't evaluate the integral, just do the u substitution, and we've done that now. All right. All right, let's go ahead and look at our last question here. It's an FRQ review. We had this over the weekend. Let's begin. It says, the height of a tree at time t is given by the differentiable function h, where h is measured in meters and t is measured in years. Selected values of h are given in the table below, not above. Typo. All right, part A says find this integral here and interpret the results providing the appropriate units. All right, so first of all, if you integrate h prime, you get regular h. Then, using the fundamental theorem of calculus, we would have h of 7 minus h of 3. You plug in the top number, you plug in the bottom number, and you solve. And from our table, we could see that at 7 years, h is 11, so h of 7 would be 11. And at 3 years, h is 2, so h of 3 is 2, and we're left with 8. So what are these units? Well, basically, this is the height of your tree at the 7th year. This is the height of your tree on the 3rd year. And 8 would be how far apart those things are, right? So basically what this means is that from the 3rd year to the 7th year, our tree increased by 8 meters. Oops. Okay, so let's go ahead and talk about how this would be graded and the things that we're looking for. All right, so first of all, did you get 8? Okay, that would be worth a point in and of itself. Then you have your interpretation. The interpretation would also be worth a point. Now the interpretation has to have 3 parts to it. It has to have the input units, which are years. So I put t equals 3 years to t equals 7 years. It also has to have the output units. That would be the 8 there. So the output units are meters, so it's 8 meters. And then finally, the rest of it is it has to, basically, you're interpreting what the meaning is in the context of this problem. So that's where I'm saying that the height of the tree increased. So there's your context. So we need input units, we need output units, and we need the context of the story problem in order to receive full credit. So this will be a 2-point question. You get 1 point for getting the answer because of the calculus and the integration, and then you get 1 point for a proper interpretation. It's all or nothing, so you need to have all 3 parts in your interpretation if you want to get full credit. Okay, so there's that. Let's go ahead and take a look at part B. This was just asking us to do an integral. No interpretation or no units are needed for this. All right, let's go ahead and begin here. So the first thing we're going to do is we're going to integrate. Now, when I integrate this, the 4 is going to stay, and the h prime becomes an h. When I integrate this, we're going to add 1 to the power and divide by that number, which would be a 2. So if I add 1 and get 2 and divide by 2, I end up with t to the 2nd power. And if I integrate this, I end up with 4t. So the first step is to integrate your function. The next thing we're going to do is we're going to do our fundamental theorem of calculus. So we're going to do our little setup here, right? For the first set, we plug in the top number. For the second set, we plug in the bottom number. Then we're going to start simplifying. So let's start here with h of 10. h of 10 is 15. So this is 15 times 4, which is 60. 10 to the 2nd power is 100, and 4 times 10 is 40. Next, we are going to do this one. So let's find h of 5 first. h of 5 is 6. So 6 times 4 is 24. 5 to the 2nd power is 25. And 5 times 4 is 20. All right, then we're going to distribute our negative once again. I'm just going to rewrite all this. 60 minus 100 plus 40. And when we do this one, all the signs are going to change because we distributed the negative. All right, and now we're ready to start putting things together. Let's see. If I put these together, I get negative 40. And then if I put these together, they cancel out. Negative 40 and 40. If I put these together, I get 1. And if I put that together with negative 20, I get negative 19. So looks like my final answer there would be negative 19, just combining all those numbers together. All right, so that'll do it for our Unit 2 Quiz 2 study guide. Hopefully that was helpful. And there are some odd problems if you guys want to practice a few more of those. If you want to see more FRQs, I'd say look back at the weekend homework, because this is the only one that's on the study guide. But other than that, we'll see you guys in class, and good luck on your quiz.